mic down.
My mic is on. How's everyone doing today?
Good.
Excellent. Well, hopefully we can keep your week and months good, because soon you'll know how to debug a little bit better. I come from the embedded programming world. That's like the little chips that go in your toasters, your VCRs, your cable boxes, your gas pumps. That was where I came from. So some of these approaches are done a little bit differently in the embedded world, but that's definitely where I got the start in this area. I switched to iOS in 2008, so that's why I've been doing presentations for a number of years, because I've been around for a number of years. What I do for a living is I do the iOS consulting thing where I go make apps for people, but I also do risk management, basically making decisions on this is the thing you should work on versus that other thing based on how much money it would make you versus how much time it would take. And I already mentioned the other thing that I released this week. So, errors. Errors are the thing that are wrong in our program. It's the thing that doesn't work the way the story we've told ourselves says it should work. Faults are the actual small piece of code that is wrong. So the problem we are facing, generally speaking, is finding that small piece of code. Fixing most of them is actually typically a pretty small problem. Occasionally it's complicated, but generally speaking it's almost a typo or things like that, but it can be a typo that takes us 3 weeks to find if we're not lucky. So I view debugging as something that you only want to do in a way that you know the steps you're taking. That makes it so you are more confident when you are stepping into this. When you get setbacks, you know what the next step is to take. And you don't have to deal with the emotional turmoil of 3 weeks of having no idea what's going on, because it didn't take you 3 weeks, because you went through the right steps rather than just haphazardly trying things, pasting stack overthrow code things. So here are the principles that I go for. Read the manual, fix all the windows, reliable reproduction, cartography first, use your eyes, not your confidence, split the map, and act like you have a fast computer. So the first one in order is read the manual, but a slight detour. In this talk, I'm going to talk about tools. And this is a very important quote from Henry Ford that I think it's considered to be possibly apocryphal. But if you have a machine and don't buy it, then you'll ultimately find that you paid for it and don't have it. What that's basically saying is you're going to waste enough time and resources if you don't buy something, especially something affordable, like all the tools I talk about tonight, when you need that tool to get your job done. Hopefully, you'll find yourself blessed with a company credit card and a small amount of discretion if nothing else in your job. But if not, you still often will want to spend your own money at some of these things because they make you look quite a bit better because you solved the problem in like 20 minutes rather than 2 days. Okay, reading the manual is the first principle. Lots of people have told themselves stories because they heard them secondhand how a company works, or they've seen how things work, and they have made a inductive summary of how it works in their mind, but they never read how the person who created it says it works. Generally speaking, you need to go do that when you are debugging. If you don't do that, you're just going on that story you told yourself. And we'll get more to those stories later on. So you need to stop, open up the documentation of if Apple made it, or if it's a third-party tool, you often have to open up the source and read the source that the third-party tool did. Sometimes the documentation of third-party sources is good, often it isn't, so I would say the source is generally your guide there. When it's your own company's code, or it's a third-party set of code that has comments, you need to verify those comments. In the iOS world, we use comments a lot less than many other different areas do, and that's actually a bit of a blessing because we don't have to do this as much. Comments go out of sync with the code they're next to, and they're often not related to what the function is. So what you want to do is you want to get in your source control. Git has a function called git blend, but I believe there's one in Mercurial just like it. And you want to see when the comment was changed or when the code was last changed in any function in the path that you're checking for debugging. And if that code is newer than the comment, view that comment as possibly blank space. And a lot of people, especially people new to coding, They copy and paste from Stack Overflow, but they also do big long answers. Remember, anyone can write a big long answer in Stack Overflow, but only specific people can write a big long article on Apple.com. So you have to remember that those things could be wrong too. It could be someone very confidently stating the wrong thing, or it could be very confidently stating what was true 3 years ago, and that person's out of date. So that might be valuable information, but it is not the documentation. And that's important to remember. You're not reading the manual. As far as tools goes for reading the manual, this is an awesome tool. If you're gonna buy any of the tools tonight, and if you ever travel anywhere where the internet is bad, buy this tool. It's an offline documentation browser. It downloads all of the documentation for the particular language you're in. You can also download any Stack Overflow tag in its entirety from Stack Overflow. Literally, you can download all the, if that's what you like, you can download that. And you can bring it up with a keyboard command and search easily. You can make your own doc sets, and if you release doc sets for your product, people will see it as well, and they'll, maybe investigate your product because you're good at documenting things. Okay, the next one.
I have to say, Dash is awesome. He can't overstate it. I mean, it's phenomenal.
Yeah, and it's cheap. It's only $25. So the next thing is, lots of people, when you look at their code, and they're often embarrassed about this, there are warnings. And there's two places warnings can show up in your code when you compile it. One is on the third-party code that you use, and second is on the code that you made internal to your own company. The third-party code, I would challenge you to consider making an open source contribution that fixes those warnings, because almost everyone will accept those. But if you don't feel like you have the time, just ignore those, and they are divided enough that you can see that those aren't there, that those aren't in your code. The problem with warnings and other things like that is when you're looking at your code in the IDE, you will miss subtle errors you've introduced if there are a bunch of warnings that are essentially meaningless floating around. So by getting rid of them, when you cause an actual problem that the automated tools can tell you, you are instead going to not notice it. It's going to get buried in the pile. Past warnings, there's something called the static analyzer, which a lot of you run, but some of you don't. It's in the same build menu up at the top. And what it does is it does an extra long pass over the code. It's looking for good things to have done. And generally speaking, while warnings, sometimes you need to suppress them by putting pragma directives above and below it. Almost all static analyzer problems are real problems. There's something you probably should be doing a little bit better, and it's probably worth the time to do. So I would say for analyzer errors, fix all of those. And whatever you don't fix, there should be comments around your suppression saying why this isn't a problem for you. Because those comments, while they might go out of date, until that pragma's gone, future people will be lost when we come to it. And you might be that future person who's lost. So you're often doing yourself a favor. But what is the tool that goes with this is the next layer. You have the warnings, which you always see when you compile, then you have the static analyzer, which you have to go look for. Then there's faux pas. Faux pas is like a static analyzer on steroids. It has some very aggressive rules, such as lint did back in the C days. So you're probably only going to use something like 2/3 to 3/4 of the rules. But the default set's okay. And basically it will go through your code and say, you really shouldn't be doing that thing because this sort of function should never ever be used that way. And sometimes it will be pretty strong. Other times it'll say, this is a warning. You probably shouldn't be doing this, but you might be doing it right. So I suggest, again, absolutely everything is either suppressed or dealt with, and you don't leave any noise here, because this will tell you what the problems are before you have to get through to debugging, this one is wrong, because if you fix all of these, you may find yourself with a perfectly working code base, because this makes your app not work well with some of these errors. Okay, so now we've talked about the preparing yourself by reading the documentation, preparing your code by fixing all the broken pieces. The next thing is being able to find your bug every time you go through the code. There's nothing worse than having a bug that shows up 1 in 20 times, because you spend 19 out of the 20 times wasting your time, and depending on how you have to get to the bug, that's really frustrating. So here's some of the ways we can get get there faster and more reliably. So in your code, you will often be initializing variables from a function call. What you often do when you want to reproduce a bug is you instead initialize the variable from some static data that you pulled out of the function call the one time that stuff was really failing. And that's similar to what you would do in testing, but you don't have to rejigger your code as much as you do to make a lot of the testing methodologies work for this. So you just comment out the code and you insert the fake data. Sometimes you're not just pasting some code in with the data. Sometimes you're reading from a file, or sometimes you're installing a library to fake the network, but you're still, fundamentally speaking, inputting fake data, and that makes it so your bug will show up every time. Therefore, you have 20 times as much time to deal with the bug, rather than those 19 times when you're trying to get it to pop out. The next thing I have here is something called generative and property-based testing. They're the exact same thing, they just use the terms interchangeably. There was a framework in Haskell in the year 2002, I think, called Quick Check. And basically the idea is you produce a function that produces input to your system that you're checking. And that function should generate all sorts of different inputs that should be valid inputs that the function will return a result for. And then you put on the other side of it what the function should return the result for. And the program will run the generator like hundreds or thousands or however many hours you can leave it running on. Like you can leave it running for days if you want to. It will keep running things until it gets failures. When it gets failures, here's what it will keep doing. It'll keep running and until it finds the smallest failure case. And small failure case, that doesn't seem like that makes a lot of sense. If you have an array that fails when the last numbers are -1, for instance, or is smaller than one of the other ones, it will run enough different examples that you eventually get 0, 0, 0, 0, -1. So you get this very clean piece of input, but it's often like obvious why your code's broken. So while it's a testing framework, and you could go do it with testing, you can just bring the testing framework into your project and run a generative test just for input for that one problem that you're facing today, and thereby get your debugging done. And you don't have to adopt this wholesale across your product or anything like this. You can just do it today to find the inputs that make hard to duplicate bugs show up wrong. Another thing you can do is chaos causing systems. If you have bugs that show up in the field, that show up maybe on someone else's device a lot, if you start doing things in your system that generate a less ideal environment, such as turning things on and off, or using things that hit the screen randomly, you can often find a reproduction of a bug that you yourself can't generate very well. These are very good to get a failure case that you can constantly reproduce. And constant reproduction, gives us 20 times as much time as random reproduction. Next place we can go is the new UI testing that Apple put out, or the old UI testing that people like Square put out through their TIFF framework. You can use a UI testing framework to basically hit the buttons on your app. Because sometimes, or scroll your app up and down repeatedly, or slide it left and right. Because sometimes it's only when you scroll a certain way, or the network's in a certain way, and matching up with your scroll position, a lot of cases that involve timing, basically, that having someone constantly repeating a UI action will make it so you can get a reproduction installed. So, again, you're not adopting that testing framework. You're not changing how your company's doing business. You're literally using the test tool just to debug one problem. And you trained yourself on the test tool too, which can be useful if you decide to adopt that in your company. Lastly, on reliable reproduction. Abuse systems are something that you'll see more and more on servers these days, because back a decade ago, it was pretty normal that you could talk to another website and hit its APIs and get something out of it, even though if it was an API that was really for internal use. Nowadays, there's often anti-abuse things, timing backouts and things like that. Those timing backouts are anathema to reliably reproducing a problem, because what would happen in normal production code is it's this person hitting it, and this person hitting it, and this person hitting it. But to reproduce, sometimes you need to hit it 20 times. So definitely you need to gain the privilege and the tooling at your work to be able to turn off and on those abuse mechanisms. So at least on testing, you can get a reproduction done faster. Like I said, there's tools. The first one is the Apple one about using the Apple tool. There's actually a video of using KIF by me a few years ago on the web, which I should have probably referenced. These are the two generative testing frameworks for iOS. This one is the one that's written in Objective-C. This one's the one that's in Swift. Of course, this one definitely works for both. I don't know if the Swift one works for Objective-C only. All of these slides will be posted, so you don't need to take pictures, but you can if you want to. And this generative testing video is a wonderful presentation that should be watched just because it is a wonderful presenter doing a wonderful presentation. But it will teach you what property-based testing is doing, and you will figure out easily after seeing that how to use this to generate reliable reproductions. Our next principle is cartography. Yes, it's the fourth point, and it says cartography first. I'm aware of that, but it is what you often should be doing first in your debugging. So I don't want you to go through and make one of those charts that were very popular in Microsoft presentations and books around the turn of the century. You don't need a comprehensive UML diagram of your app. As a matter of fact, I think that would actually be harmful to do your debugging. But you do need to say, oh, this seems to be happening somewhere around when people use that screen. And then you need to draw out everything that gets data to that screen and everything that comes after that screen in your code. You should, generally speaking, not be doing this on a computer. You don't want to keep this thing. Generally speaking, debugging is just a pure cost center in your business. You do not make money by fixing bugs unless literally it's the money-making code that has a bug in it. And then it's more like you just stop losing money. So you want to quickly draw a piece of paper, and you want to throw it away. You want to throw it away because no one is going to keep this drawing up to date, so it is going to be misleading to future you or someone else who comes after you. To do this drawing, though, you may not yet be prepared. You may not yet know enough about that subsystem because you may not have written it. That person may not be here anymore. Or someone may have copied and pasted some code and not really understood what it was doing, or have never really understood exactly with this method came before that method in, say, something like the view controller lifecycle. So you may have to go read one of those really deep dive documentation papers Apple puts out, and then you may have to go stalk Apple employees on Stack Overflow and read what they're saying about it to really get deep enough to draw this map, because you won't actually be able to find a problem sometimes if you don't know how that stuff works. But you go learn the things that are actually between the beginning and end of the data flow that's broken, and then you can start drawing the map. Lastly, there are several technologies, especially in the last 3 years, that have come out that make iOS apps more asynchronous. Grand Central Dispatch, the dispatch async and dispatch sync calls, NS notifications, like the ones you use inside the app, local notifications and remote notifications, all are asynchronous. So when you draw this nice little diagram of going from so-and-so to so-and-so to so-and-so to so-and-so, so you have to figure out where those asynchronous things could come into your system, and they're not necessarily going to map very well. But they can be what is actually causing the problem, so you do have to include them on the map. Now, I want to show you what I mean by low effort. I mean this by low effort. I'm standing up in front of a room picture, people showing the crappy picture. All of your maps should look nothing better than this. No time at all. This maybe took a minute to make. We'll get back to this map when we go through another one principles. So, just draw yourself a crappy map, and then we'll work from that to find your bug. Okay. Like I said, errors are the thing where we told ourselves a story about how the system works that's wrong. Fault is the actual tiny wrong piece of code. To find errors, we must use our eyes instead of having confidence we know what is wrong. In American business culture, there's often a problem where you're in meetings and someone asks for an answer and people speak up even though they're spouting a mix of about 40 to 50% bullcrap. You have to not bring that habit into debugging. There's a lot of people who tell themselves stories and want to feel like they're really very good at what they're doing. And you need to sometimes eat some humble pie and say, I don't really know exactly what's going on here clearly because there's something not going on with the way our stories say they would be. You have to basically say, this is known true, and here are the reasons it's known true. I put this data through it. I put this through this test. I put this, so that this one is true. But this thing over here, I think it does this. I have a hypothesis it does this. In the US, there's been a lot of conflation in the media about what the word theory means in pop culture versus what it means in science. So I would say, because of all the damage that's been done there, when you're debugging, you want to keep that out of the nomenclature of your company, because people will talk about their explanation as a theory, when really it's just a hypothesis, it's a story they've been told. And those can be really harmful in finding the actual solution, because they've told that story so many times that you just, you're missing the very obvious root problem. One of the ways that you break down these stories and change it into something that's actual fact is you go into your code and you put an NS assert that will literally crash your program if the story is wrong. You say NS assert, thing that has to be true, and then you say, here's the print statement to say when it's not true. The Apple assert version does not crash production apps. Several other people think it should crash production apps, so they write their own version of NS assert. It's not really that hard to crash an app. So you put those at the beginning of functions that say, here's what the function must have. And then from then on, when you're debugging, you know the function really does have that, as long as you wrote your NS assert right. Additionally, you can write preconditions, which might return with a slight error, or might do some initialization. Those can get a little tricky to debug, but they're all right. And then lastly, Apple added the guard statement this last year. It's basically a way to return runtime errors of preconditions that this code must have. We generally think of guards as the thing that makes optionals into non-optionals, but the real reason you want them is because you want to make it so you know things for sure. And that's a lot of what the idea of optionals versus non-optional types are. With non-optional types, you finally know things for sure. We're basically doing eyes out confidence with the static type system. Additionally, when you're using your eyes and not what you think, you're looking at things. You are using things that allow you to see what the data is. One of them, which I think everyone has probably seen when their code is crashed and it pops to the line that's the problem, is the debugger that's in Xcode. It allows you to go to the next line of code, the next line of code, the next line of code. It also allows you to go up a couple functions or down a couple functions. We'll go a little bit more into breakpoints a little bit later. You can just have your program print out a lot of things. You can have it put it to a file, or you can just have it print out on a little screen. We'll get more to that later. But that is definitely a way to see what is happening rather than think about what is happening and maybe be wrong. Something that is not as important today as it used to be, but you definitely can still do it, and it's cheap to do too compared to some of the other stuff, is when you're debugging views. Rather than saying how all the constraints are working, where exactly this view is or that view is, you can just color some of them different colors, and you can basically make it look like Easter Bunny came in and ate your UI. But you can literally see all where those little white boxes were that you have. You can say, oh look, there's a big box right there. That's not the size it's supposed to be. So you're looking, rather than telling yourself a story and using what you're confident is right, you're looking to see what who here has seen the explosion of constraints can't be satisfied in the room pop out in your console? A lot of people don't know. There's actually a field that you can click on the constraints in IB, or you can set them in runtime code if that's how you build your constraints. You can set the identifier field. And it will actually just say the identifier down there rather than like some really hard to figure out what constraint is broken. So again, that lets you see what is wrong rather than having to find it. And we'll get to how to use these correctly shortly after this. But many libraries, including popular networking libraries, database services that just shut down recently or started to shut down recently, and things like that, have debug modes for the libraries. And it's basically, you set a variable or you call this particular function that you found out by reading the manual, and it will spit out tons of data. Core Data has one of these, and it will spit out tons of SQL stuff that you, generally speaking, will not be able to sort through and get any useful information out of. These debug modes should be turned on very judiciously, but they can give you the exact amount of information to know, yep, we got here, and nope, there's not a problem here. So that's definitely another way you can check with your eyes and not the story told her so. But just like with all the broken windows that we were fixing in the fixing all the windows section, anything that you are past, anything that's already in the section that you know is right, turn off. You want your brain to not have to think about what it's seeing more than it has to, because you're actually doing something that requires a lot of executive function. And executive function is very tiring to people. You will just wear it right out if you keep all that stuff on. I've seen so many apps when I come and sit down, there's all these print codes of like, I got here, and it's like printing out data, and no one wants that anymore. No one ever needs any of that. So turn it off by module, turn it off by however you need to, including that debug mode if you turn that on. Turn it off very quickly. Now, all of these things are things you can do without editing your program, really. Like, yeah, DNS inserts, you're editing your program, but you're gonna keep those because they're cool. And they give you truth for the future. But sometimes you have to put panels in to give it the ability to put more data in. Or you need to put panels into the ability to get more data out. Sometimes you might need to display something you got over a network, say a picture, because it doesn't display in the native iPhone format if you just use the debugger. Or it might be a movie, you might need to play it to see if it's right. So sometimes you actually have to go write a special module of your app, and you don't have to write it with very good quality, but you do have to go literally write another screen. It only pops up so you can debug a single problem. Keep that code around, but don't leave it in your live app, of course. But sometimes you have to do these things to find the problem, and it's again, you're looking for the problem, and you're letting your eyes see it rather than telling you a story about how it's working. And that makes it so you can be certain things are wrong, and when you go to your boss, you can say, well, we don't know what the problem is, but we know it's not these 27 things, because you literally have a list of things that you've been eliminating. And if nothing else, that can make it so you can have some more political time to solve the problem. Okay. Unfortunately, the talk window is only 45 minutes long, so I didn't really get a good debugging thing that fit in as an example. But here's a debugging feature that comes with Xcode that I wanted you all to see. When you're using the debugger, most people just tap a number and there's a breakpoint there, and then when they run the app stops when it gets there. Then they hit a play button and it starts resuming and going. If you, I think it's right click or command option click, it's muscle memory, I don't remember. Is it right click? Yeah. You get this little menu right here. This, I don't know how well it shows up for you guys, but this field right here, you can basically set a criterion. And what that criterion does is that's when the breakpoint is triggered. So it's basically turning it into an if statement. It also says ignore, so you can make it so it's one of those things that doesn't happen the first time or only happens the 177th time. You can put a big number in here, and you don't have to change any code to do this. And you can also make it so it doesn't even stop, really. It basically does a little thing that keeps going by clicking a checkbox. Lastly, there's a button that allows you to add actions. This was actually a lot more useful in Objective-C than it is now in Swift. You're basically typing in the console that you can pop up when you're programming. You're basically typing a console command right here. So Objective-C was a little bit easier to not cause crashes, like getting playful there. But some people, they say no printfs in the code, only use these conditional breakpoints. I personally find breakpoints very disposable, so I use them for a debugging session and get rid of them typically. But this is a very powerful way to see into the code and to make it so you're not constantly trying to reproduce something, or you're not manually checking a value over and over. You just put one of these in, and it only stops when the value is in the problematic value. This is an article right here that I actually stole this picture from, and it is a great resource on learning how to do this.
Can I add one thing to that?
Yeah.
So you kind of touched on it a little bit, but yeah, so as you're putting log statements, and you might want to keep those log statements around, anytime you feel like you got to do a got here log statement, you should do it in a breakpoint like this, because that's no good to anybody anywhere else. So if you do it here and do an add action and then do a log and then put got here there, then it's never going to be in your code again. When you get rid of it's only in your Xcode. It's not in the repository, and so it's a much easier way. And you can have it to where it actually doesn't stop at the breakpoint. All it does is log in when it gets there.
Yeah.
So.
Yeah, if you click that little checkbox right there, it basically acts like he was talking. Again, on the eyes section, I was saying we used to have to color views. The reason why we don't have to anymore is because Apple put this app, some people call it Sherlock when they do that, they put this app in Xcode. Well, rather they put the subset of its features. So there's two apps that do this that weren't Apple. There's Reveal and Spark Inspector. Spark Inspector is the one I own and use, but Reveal is okay. It wasn't like it was a lot worse. But they're both under active development. I think Reveal is more, this one's $50. So what it does, if you've ever had one of those car fixing catalogs that shows the exploded vision of the car, it basically takes your UI and makes it so all the different pieces of this UI show out like this, and that really reveals problems with the UI. So rather than you having to go through and put print statements to get all of the different frames and doing that, you can just see it. You can also change it right here. So this goes back into inputting data to get reproducible problems. I will have to say I haven't found very many problems that have wanted me to do this for reproducing a fault, but this has been very good for tweaking things with an artist sitting next to me sometimes. But again, this is another good app, and it's only $50. And yet another looking app. When you have a networking problem that you need to look at, or you need to eliminate the possibility that it's a networking problem, you buy Charles Proxy. Again, it's $50. I know that's a lot of money to some people, but it is a lot of time saved, so I think it's actually very worthwhile. Again, what this basically is it's a professional piece of software. This isn't hacker software, but it basically launches a man-in-the-middle attack on your iPhone by putting it, or the simulator, by putting it through the computer. And then you can see absolutely all the network traffic that's going between your iPhone or your computer, or often both, and the internet. And what that lets you do is that lets you see these things that you're talking to your API endpoints with, and you can see your headers, and you can see the data, and it's a very good way to validate that the API you're getting is giving you data that makes sense, and you are giving the API data that makes sense. It's often very nice to screen share with your web person while you're doing this, and he or she may go, oh, I messed up, or she may go, oh, you messed up. And it's very easy for both of you to recognize when something's wrong in looking at this. So it's a great one for using guys. Yeah?
I will say, Charles, I use every single day, because the biggest benefit for me, a lot of the apps that we build have to reach out to the web, grab configs, pull them down, parse them, standard kind of stuff. So not only am I seeing where it's actually going, but I can actually grab the response, save it locally, remap to it locally, edit the file, and then every time it's asking the web, it's actually just asking the hard drive, and I know exactly how it's supposed to respond. I mean, it's a tool that we use every day. Our QA guys live and die by Charles.
Yeah, if you use one of those libraries like he's talking about that feeds fake information to your API fetching endpoints, wow. Charles does give you a lot of great data. But it's good even if you're not going to go to they have pretty far extents that go with it, but it's great even when you're just peeking at it. Okay, we're getting closer to the end of the talk. This seems like this would be something that would go up near the cartography, because we drew that map all the time ago. But you need to know how to do the journey that you're going to take on the map, to do the journey right. So this is splitting the map. If you have a CS education, you were literally probably taught this in like 7 classes. It's called binary search. You go to the middle of something, you check to see if your right's good. If it is, you do your left. And then you just do that over and over again. And why that's very powerful is because it very rapidly cuts things down at a huge rate. The way to think about it that's more intuitive for a lot of people who didn't get this pounded into them in their late teens. There's that parable of the chessboard where someone tricks a king into giving him 1 grain of grain on the first day, 2 grains on the second day, 4 grains on the third days, and then by the end of the chessboard, he basically has all the grain in the kingdom. When you are searching for an arrow, that same principle is occurring when we're splitting the map, except that's all the code that you've already validated is working right. All the grain, that's all the stuff that's working fine, because we keep on cutting down the area that has misbehaving code by half every time. So you take that map we drew earlier, you find what you would roughly call the middle point. I generally say, oh, that side's easier to test, so we'll call that side the middle point. Then you try one of the sides at random, or by intuition, whatever you want. I use the heuristic, oh, that looks easier, I'll try there. And then you see if the data in the middle is faulty. If the data in the middle is not faulty, that tells you which way the error is. It's downstream. You know, if things are good here and water's flowing that way, things must go bad somewhere between here and there. And if they're not, you look that way. And if neither one shows it, our map is wrong. But that happens sometimes. Then we do that over and over again. So if we have this map right here, I'm going to read you my hastily scribbled thing. This is someone pushing a save button with their finger. This is the save content button. This is a setup dialog. This is write to disk in case, you know, sometimes you have to set up the save for something or something like that. So we draw that in our map. Here's the write to disk function. Here's the save to net. Here's the update database function. Maybe it does something different than the write to disk function. Maybe it has something from the server on it. And then here's where we show 5 apples. So we have something where this is not showing 5 apples when it should be showing 5 apples. Sometimes it's showing not enough. So we say, oh, this right around here is about halfway. We're going to look right here because writing to disk, that's easy to check. So we go and we look at that data on disk. Well, the data on disk looks fine. We looked at it by opening up the simulator hard disk folder, and we looked at the actual file sitting in there in the fake documents directory, and then we compared it to what our understanding is. No, we didn't look that the data format was right, and that could be a problem I'll have to come back to later. But this is a battle of principle, it's not a battle of absolute law. So there is some judgment involved sometimes. We see that it's right, so we see that there's 1, 2, 3, 4 steps. So we're going to check this transition between saving from the net and updating database. What that means is we're going to whip out Charles Proxy. And we're going to connect Charles Proxy, and we're going to watch the JSON that's coming down from save to net that we then write in the database. Oh, look, that's not right. So something's happening right here. So now it's either at the end of this or the beginning of this, something in this transitional code. And so we find basically the start of this, and we look here. And that principle with 1, 2, 3, 4, 5, 6, 7 nodes, we'll find it in like 3 checks. But if you have 64 nodes, it'll still find it in like 8 checks. That's a lot less time than randomly going through your code places, just as long as your map contains it. So splitting the map is a big heuristic. It's intuitive to a lot of people, but other people, they just like, I don't really want to draw the map, so they don't really know that the setup dialog is in the map. So if our problem was in there, they never find it because they didn't draw that into the flow. So draw the map and split it. That was a simple one. This one is a little bit hard to get some organizations to swallow. Your boss may not like this, but it is the way to be sane and to keep your executive function around. So I think it's the way to find your problems faster. Even if you have the new MacBook that compiles like 1 Swift file a year, you need to pretend you have the top of the line 5K Mac. You have to pretend that it's okay, it will take time for things to work. So when something is wrong and you decide this is the thing I might need to do to fix it, you change it, and that's all you change. You don't do 3 other things that might fix it. All of that, oh, we're going to get a lot of things done. All of that happened in the fix the Windows step. Now we have no excuse. Now we change one thing, and one thing. We do the compile, and if it's taking time, we doodle down some notes that say what our hypotheses are and what our things are that are known. And then after that, we don't worry about the fact that there's some time we're sitting here twiddling our thumbs. Hard for bosses to swallow, but it is literally the thing that will keep you sane, will make it so you find your problem quickly. Additionally on this note, the simulator, while it sometimes acts differently, or you have to do certain things to make things like location services work on it, the simulator is so much faster than copying to device because just there's no cabling involved and there's no signing involved. You want to move everything you can to the simulator. You want to pretend that you bought this really nice phone and I have this really cruddy computer, but you still almost always want to do it on the computer. There are exceptions to this, mainly in the graphics and game programming area where the phone actually will perform better than the simulator. But generally speaking, you want to move everything over to the simulator on your fast computer, no matter what it is, and do it one at a time in a methodical way. Slow is fast here. It is not something that you can get away from by going quicker. So, in review, read the manual, fix all the windows, figure out a way to make your problem happen every time, draw yourself a map before you randomly go poking, then look where you're poking, don't think about it, just go look, figure out what's really going on, don't tell yourself stories. Then you find the place halfway through the map, figure out which side the problem's on, go halfway, figure out which side the problems it's on, then repeat. And lastly, make sure you're not trying to do too much just because the compile is slow. That's how it works. Here's the places you can catch me on the web. Thank you. Any questions? Well, I have a couple minutes left.
What was the exact pragma for making errors, like ignoring errors?
It's Pragma Push Error Diagnostic. I don't remember off the top of my head, but I mean it's like 1,009 places on Stack Overflow,
Really?
and it's in the doc, in the Pragma doc to grab it. Anything else? Oh, and it's a pair. It's a push and a pop at the bottom because it's turnabout
Yeah,
diagnostic.
it's got Warren in it.
You can turn off Warren and you can turn off something else too.
It's like Warren and it has a push and a pop, so you turn it off in that section.
Yeah. Anything else? Okay, thank you.
Awesome.